let's do this. All right, so be careful now. Let me explain something about this formula sheet. No notes on the formula sheet. No words on the formula sheet unless I say you're allowed to have a word on there. You guys with me? Any extra stuff that's on there that I said that didn't say that could be on there, you'll lose points for. Little symbols that you create for yourself, that's your own shorthand for notes. Nah. I don't want any rips, tears, markouts, because I don't know when those happened. Does that make sense? If it doesn't, I don't care. Just don't do that. All right. I've got to assume the worst. Otherwise, it's not fair for somebody to have more than somebody else had. Maybe? Maybe. Okay, so here's the formulas. Chapter 1, no formulas. I mean, it's all beautiful definitions. That was so much fun. And then chapter 2, you might not even want to write these down, but maybe for the symbols, right? You got these two that are the same thing. What's the only difference between those two, really? They're both what's, but this is for what and this is for what. They're both means, but this is for population, this is for sample, kick-ass, right? So you know, you can't write next to this population. It's a word. I didn't say you could have it. In fact, I just said you can't. Right? Yes? No, that's what I don't even write it down if you don't want to. We know how to get a mean. So if you don't want to write that down, so you don't freak yourself out, you know how to get the average of numbers. That's fantastic. That's why I love this, though. This is just our first step, or it was, into the symbols of statistics, just to see how they match up with what we know to do in English. Add them all up, divide by how many there are. Bam. I love it. So that symbol there means add all up. Is what? The shit that's here. Like, how often do we see the symbol? A lot. We're going to see it more and more and more the whole semester. It's always going to be the same thing. Add up the stuff that comes after me. You guys all right? You guys have a rough weekend? I'm sorry. Or a good weekend, so it's a rough morning? I don't know. Or 7 something. I understand. Okay. Then we got these guys. Why are these different? There's kind of 2 levels to that answer. What are these, by the way? Not quite standard deviation. What are these? Variances. What have I not done yet to get the standard deviation? Taking a square root. I love it. This is the variance for a population because it's a Greek letter. This is the variance for a sample. Why is this one different than that one, the formula? You don't have to know everything besides what I told you. I mean, this is just a poor little sample. So this n minus 1 is an adjustment because it's just a poor little sample. It doesn't know the real mean. It's only got its estimate for a mean. So this n minus 1 is an adjustment for it being just a sample mean. That's the best way to look at it. If you know more math and you're curious about why, you can look up proof of the standard deviation formula and you might be able to get through most of the steps. If you know some calculus and stuff. If you don't, maybe leave that alone. Okay. Then we got this guy here. Let's see. This is kind of like our first use of the standard deviation. My claim right now, and I'm going to stick to it the whole semester, is any z-score formula we use is always the same. And some of you guys are already like, Jeff, you just wrote 2 z-score formulas up there. But these are the same thing. Our data minus the middle divided by the spread. Our data minus the middle divided by the spread. It's always that, always. Let's see, what have I forgotten? Oh yeah, I don't know if we officially wrote this down, but let's do this. If you solve this for x, you get this little guy. Bless you. And if you did the homework, you use that idea. What's a z-score tell you? Anybody remember? What does a z-score tell you? Anybody remember what's a z-score tell you? The number of something from the something to the something.
It's the number of standard deviations away from the mean.
To a data point. I love it. That's what a z-score tells you. The number of these that fit into this. So the number of standard deviations from the mean to a data point. That's what a z-score tells you. And then this formula, this is hilarious. I don't let you have notes on a test. But a formula is a note. A formula is a math sentence. How do you get to a data point? I start at the mean and I go this many of these. What's a z-score? The number of standard deviations from the mean to a data point. Any formula that you've ever seen you can read in English. It's just a translation. That's what taking a math course is learning how to translate from one language to the other. Okay, all right. Anything else I forgot? Do you guys, any other formulas you want to suggest? I'm open to suggestions. You got to know the class width formula for histograms. You just got to know it. Anything else you guys want on the formula sheet? Okay, that's it. That's all you can have on the formula sheet. All right. Everybody heard me when I said you will lose points on the formula sheet if you have more on there than I said you could have. Everybody heard. All right. If you're not here, the video's up online. So don't cry to me when you lose points. Okay, I love it. It's still going to happen, but I will. I'm used to it. All right, so now that that's all over, there's the formulas. We can get into questions. Yeah.
Is class width formula in somewhere in chapter 1? Or
I don't know. I don't know if it's in the book or not, but we went over it. How to get the class width. You can't put it on your formula sheet, but beautiful. It's the high minus the low divided by the number of classes. I like it. And I'll tell you how wide each class has to be so it covers that range of data, high minus low. Kick ass. Okay. So now it's wide open. I have nothing. I've come with nothing because it's complete room for questions. I've got the answer key for the practice test that I will not give you yet. I'm trying to trick people into staying. Oh, okay. So we got all these. Somebody still going for it? Okay. I'll leave those up there. So what did you get for, so 1F says what percentage within one standard deviation of the mean, right? What did you get for the mean? Okay. And what did you get for the standard deviation? Cool. So this is from part, what was it? Part E. Is everybody with me so far? So I want to know within one standard deviation of the mean. So a really smart thing to do is to put a little number line, put the mean down. How far do I want to go up and how far do I want to go down to be within one step? That word within sometimes confuses people. Within doesn't just mean up or down, it means both up and down. If I wanted you to be within 1 pound of the right weight, you could be up a pound or down a pound. That's within. Within implies an interval. So 1 step down, how big each step? 8.575. So you take 45.7 minus that, and 45.7 plus that. That's taking a step up and a step down. See how far you get. That's step number one. So what the hell you get when you do 8 minus 8.575? $37.125. Nobody's going to help me. All right. And if you add 8.575, looks like you get 54.275. Yes, no, baby? I could always look at my key, because I have my key. Ha. I like to do this to remind myself that this is sort of a interval. This is a net I'm throwing out. So how many fish did I catch? How many of the data points did I catch? Did I catch 29? Is 29 in here? No. See, sometimes I think you're just looking at it wrong. It's very simple. 29 is not in there. It's way the hell down there. What's the first number, the first data point that I catch in here? 38. So I catch 38 through what? What's the last data point that I catch? 53. So to me, the easier way to do this is how many data points do I not catch? 29 and 34. That's 2. 63 and 55. So that's 4. So I caught 11 out of 15. Say again, sorry? Where's 37? Is it in here or is it below this? To be in here, you have to be bigger than this, right? Is 37 bigger than 37.125? No. So it's right there. It didn't make it in. That's it. That's it. Everybody makes so much out of this. It's just once I know how far I've gone out, I just count how many data points did I catch. So if you count all these numbers, you get 11. Out of how many? Total. 15. So then you can just make that into a percentage. That would be the percentage that I caught. Yes?
Just ask, if it lands, hypothetically, if it lands exactly on the line, does that count within, or is
You wouldn't count it.
You wouldn't count it?
Yeah.
Okay, just make sure.
That's why it's a parenthesis, not a bracket. I don't know if you remember that from interval notation. Yeah. Bless you. Very often in statistics, we don't count it if it's exactly equal to something. We don't count it. Yeah. Not all the time. And not every statistician, so have fun with that. Statistics is still being figured out. Yes? Are you cool with, there's 11 data points from 38 to 53. So this, I caught 11 data points out of how many? Bam, 11 out of 15, make a percentage. What is a percentage? Part divided by whole, always. I think high school is doing you a disservice. They're not teaching you well enough. They suck. You guys come in here not understanding percentages at all. It sucks. And how important is it to understand percentages? Stupid important nowadays. All kinds of crap being thrown at you, you're just going to accept it. Sounds good to me. Sorry. Alternative facts. That's what they were originally called. Okay, cool. I like it. Yes. If you put as a decimal, I'm not going to take points out. I'm going to put a little note. I've heard that humans like percentages better. I love saying I like that. All right, percentages make a lot of sense to us. That's why we created them. Yeah. But if you don't, it's technically not wrong. Yeah. Yes?
I've been noticing lately that, whenever I try to get the cumulative frequency, I always get 1.01 or 1.02. Like it's not exactly 1.
Yeah, 102% is too far. But anytime you round, it's not going to come out to what you would expect it to come out. Sort of like when you do the table for standard deviation. What's this column supposed to add to? Anybody remember? It's a nice check to make sure you're doing things right. This column should add to 0. But if you round the mean, or you round any of these, or you do both, this could come out to be negative 0.5 or something. Or positive 0.5, whatever. If it comes out to 2, no, that's too far away. But if you round it anywhere, this is probably not going to come out to what you expect. Because you might have rounded up more than down, or vice versa. You guys with me? That's why rounding is actually a huge concern. You normally don't want to round it all until the very end of a problem. But yeah, if you don't get 0 here, doesn't mean you're wrong. It just means you rounded. But if you get 2 here, that's a little too far away. That probably means you've made a mistake. Yeah. Okay. By the way, you guys, I forgot to say this. I gave you back your quizzes. Everybody knows this is your first correction attempt you can make. So corrected quizzes are due the day of the test. You could turn it in after the day of the test. You just won't get back as many points as you could have. You could turn quiz 1 corrections in on the day of the final exam. And if you get enough of the corrections right, you might get a point back or something. Does everybody understand me? So the later it is, the less points you could get back. So it's due the day of the test if you want as many points back as you can get. If you got an 80 or above, you can get 5 points back, up to 100. If you got below an 80, you get a point for every 4 that you missed. So if you got a 64, how many points did you miss? 36. Divided by 4 is 9. You could get 9 points back if you do all the corrections and get them all right. I like it. Yes, I'm big on partial credit, which is what every math teacher should be. If anybody uses Scantron, they need to teach something else. Yes? Anybody remember what I said about standard deviation? At least 3 decimal places.
Okay, so rounding to 2.667.
It is
2.667.
Oh, okay, 2.267, sure. Okay. At least 3 decimal places. I love it. There are going to be a few other things we round to 4 places, so if you just want to take everything to 4 places, that's good. Yes? So what's a more straightforward way to say relative frequency distribution? I'm going to make a what? A table. And I've got to go all the way to show relative frequency, which is another word for percentage. Right, so you don't want to stop at whole numbers, basically. So this is where you're going to do something like classes 40 to 49, 50 to 59, blah, 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 7, 8. Let's say there were 58 total. So that's the frequency. The relative frequency would be 7 out of 58. Whatever. 8 out of 58. Whatever. Percent. Right? If you're a stickler and want to make it just decimals, that's fine. But percentages do make a little more sense to us. Is that cool? So when I say create a relative frequency distribution, you've got to go all the way there. I'm not really ever going to want to look at cumulative frequency. Right? That was in the book, just in case you see it out in the wild somewhere, but I'm not going to ask you that question. It's just one stupid more step, really, to be honest. If I ask you to make a relative frequency distribution, you better make sure that this scale is involving your percentages, not your whole numbers. Yeah, so if I ask you to make a relative frequency histogram, make sure that this relates to the percentages, not to the whole numbers. Yeah. Also, what would the scale look like on this axis for this problem? What would go here? Now, some of you guys might not have made it look like this, right? Some of you guys would have said this class was this. And this class was this. Then you can use the whole numbers. Then you can use 40, 50. If you don't set this up this way, you better not set up your scale that way. They got to jive with each other. So yeah, this has some advantages, but it also has disadvantages. This has disadvantages, but it also has advantages. So it's up to you. You pick which way you want to do it. Yeah. Because what's it look like the width was? What was the width here? Not 9. 10. Yeah. That's one other sucky thing about the bookway is you can't really see the width straight across. Well, here I can see the width straight across. Oh shit, I just did this right. Then I could see it straight across. That's another advantage of the inequality way of setting up classes. It's just that unfortunately you're not as strong with algebra as sometimes you should be, and so you don't want to even look at this. Well, it's an option, so hey. Anything else from... Oh yeah, G. So what's it mean when I say 5-number summary? What is that? What's the 5-number summary? No, not yet. That would be if I asked you to make a box plot. So that's next. What's the 5-number summary? Yeah. So low, Q1, Q2, Q3, high. So how would I find Q1 if I have 15 data points? This is for number 1, so there's 15 data points. How would I find Q1? Say one more time, how do I find Q1? Well, how do you get there? How do you find it? Q1 means what percentile? 25th, so I take 25% of 15, yeah? 25% of 15. And what is that? 3.75? Yeah. 3.75. And what do I do with that shit? What do I do with that?
Round it up.
Round it up to 4. And then what's the answer going to be? The 4th number. So then I go look up the 4th number, I get the answer. Here's an example of what math is all about. You ready? Oh shit. Here goes Jeff. There's a process. Great, there's a process. Don't memorize the frickin' process necessarily. Why does it make sense that Q1 means take 25% of the number? Because what does Q1 represent? What does P25 mean? It is the data point that has what? 25% of the other data points below it. So what makes sense for a good first step to find the 25th percentile? Go 25% of the way into the list. 25% of 15. You always want to find the connection between what I do and why I do it. So often students are like, let me just make it easy on myself and just figure out what to do. But then you make stupid mistakes because you don't really see why you're doing it. Yeah.
When you look up the 4th number, do you leave it how they left it to you, or do you put it in order?
Oh, really good question. So if the data points do not have to be in order, this loses all meaning. Because then I can make any of these be whatever I want it to be. Do you see what I'm saying? So for this to have meaning, the data has to be in order. I love it. So I give it to you out of order because I'm evil. You should all know that by now. But you have a little thing that'll put it in order for you, right? So then you find the 4th number when they're in order, for sure. Just like median. Because what's another name for the median? Where's the median up here? Q2. 50th percentile, halfway. That's the median. And how do I do the median? Well, they have to be in order. There you go. So all percentiles, they have to be in order. I like it. Otherwise, I just put my test grade at the end, and I'm in the 100th percentile, actually I'm at the 0th percent, but 100th percentile, sorry. Right? But if you made like a 20, you probably shouldn't be up there. Okay, maybe. Yes?
Is there such a thing as the 100th percentile? Because with the whole, you have to average it, right? With the next number up, it doesn't exist.
Yeah, that's why we don't really have a Q4, to be honest. Right? We have a low and a high. We don't have a Q0. We don't have a Q4.
That's why you always max out at 99th percentile.
Roughly, yeah, or 99.9999999. Depending on how large a list of data you got, you can get really precise. So with percentiles, the bigger your data set, the more precise you could be with percentiles. Right? I could ask for the 37.2894 percentile. Well, if I have 15 data points, that doesn't make much sense at all. Some of you guys are like, nothing you just said makes sense. Yeah?
You could, but it just wouldn't be useful.
Yeah, I mean, it would. There's a whole bunch of repeats already. And if you start drilling down to be not just P35, not just P25, but P25.789, it's going to be the same answer. Yeah. Because there's not that many options from your data. Okay. This is wide open, by the way. You can ask questions from the quiz. You can ask questions from homework, practice test. Yes?
For the homework, section 2.3, so it's asking to find the percentile of 37.
Yes. So it's not asking for the 37th percentile, right?
No,
It's-
the percentile 37.
I like it. So there is I think I mentioned this, there's a really disgusting formula the book has that you do not have to use, right? Because for a small list of data, it kind of doesn't make sense to be really detailed on what percentile you're at. That's basically what we were just talking about. So there's a list of data, and they ask you what percentile is 37. But what's the basic idea of a percentile? It's the percentage of what, where. What's a percentile mean? So if this was the 40th percentile, what would that mean? There's 40% of the data below it. So how do you think you calculate what percentile it is? Well, a good first step is how much data is below it, right? So I'm going to accept a few different answers. Since there's a repeat, you could actually count this one too, or not. Now the book has a very complicated formula. I don't expect you to fully understand this, but for a small list of data, the formula is stupid. For a large list of data, this way basically is the same as that formula. So to me, that formula does not need to exist. But if you want to do the book way, or you're copying answers from the solutions, so you say you want to do the book way, then go right ahead and do it the book way. Maybe don't copy anymore. Right? That won't do you any damn good. So count how many data points are below there. Right? Let's say there's 11 data points below there. What am I going to do with that to figure out the percentage of the data below? Divide by the total number of data points. Right? How do we get a percentage? Okay, got this out of what? Out of the total always. I like it. That's what a percentage means. So that's how you do that problem. That's number, what was it, 24? 24A. I'm not saying there is 11. I don't know. You go do some work. Count how many data points are below this and divide it by the total.
But you don't include one of the 37s in the below.
You could. It's really up to you. But it's such a small set of data that precision doesn't make sense for percentiles, which is a small set of data. Because again, P40 is the same as P41, is the same as P42, very, very small set of data. So I will accept a different answer than the book has. Okay. What's more important to me is that you understand the basic idea. What's a percentile mean? The percentage below some data point. So that's why I assign problems in the homework like that DMV waiting time problem, right? Or the running problem, the runners, the race time problem. Can you explain what percentiles mean in a physical situation? Not just can you calculate them, whoop-de-doo. Can you explain them? Yes?
And for the percentiles, you always round up, right?
Yeah, if you do that one step, the 25% of 15 that we just did, if you do that step and you get a decimal, you always round up. What do you do if you get a whole number? Average that with the next one, 11. Kick ass. How do you check the 5-number summary in the calculator? What do you do? Do you guys remember? We actually found the 5-number summary. Maybe I'll show you real quick, in case you didn't see it. Disappointed. It's called the singing book. You open it, it doesn't. It's just, you don't want to hear me sing. Okay.
Want a howler?
Huh? The howler, yeah. Exactly. It's a whole book of howlers. I like it. So I'm going to show you real quick. Let's do this first problem on the practice test. I'm going to put that data in here. It might be the data. Oh well. All right, here it goes. So this is going to be exciting for a minute, but if you want to play along, you can just throw the data in from that first problem on the practice test. Turn you around. There you go. Okay. So how do I check my answer for the... I can check my answer for part D, and I can check my answer for part G. Where do I go to make the calculator do these calculations for me? The mean and the standard deviation and all that kind of stuff. Anybody remember where I go?
Math button.
Yeah, math is not a bad idea, but stat's a little more specific. So let's hit the stat button. And what did we just say we wanted this calculator? We want the freaking calculator to calculate shit for me. So I'm going to go over to calc. And which one of these am I going to use? Yeah, one var stats, 11. I can put one variable in there. Right? The measurements of air quality in Townsville. Townsville, yes.
The city of Townsville.
Yes, there it is. Sorry. If you don't know, that is from Powerpuff Girls. It is. All right, these look familiar. There's your mean. There's the standard deviation, 8.575 if you round. And if I scroll down, there's the 5-number summary. That's the last thing it tells me. Minimum, Q1, Q2, Q3 max. This does not mean that you go there and copy that shit down in your test and you're golden, because then you're not doing the work the calculator is. I almost don't care if you don't understand why that's not enough, because you're in this class to learn stuff. This is great to check. I will tell you this. After this first test, I'll never make you do this table ever again. Right? What is this table to do? Standard deviation. I'll never make you, we'll just get that out of here if I give you a list of data. Some of you guys might realize I've given myself wiggle room to make you do other kinds of tables, of course, but I will never make you do that table. If I give you a list of data and you need the standard deviation, put it in and do one var stats. Bam. You got it. Because that means we got other shit to do with it, right? I've already made you go through this, so you don't have to go through this anymore. Yay. So you just have to do it in the homework and on the test, then you're done with it. I won't even make you do it on the final. Haha. Okay. So that seems kind of important to be able to do. You don't have to be able to, but it's a great way to check yourself. Okay. Anything else from quiz, practice, test, homework, anything? It's be a very short day otherwise. Let me do this. Let me give you guys the answer for that practice test. Just to warn you, if you've taken me before for a different class, you know this already, but don't sit there and agree with my answer key. Do you understand? That builds false confidence. It's so easy to agree with work that's done already. I would have done that. Yeah, I'm good. No. If you did not do the practice test yourself, don't even look at this. Put this shit away. Can't really control what you do, but please, dear God, do that for yourself. Sure. Oh, yeah. So I did say we do part G in class, so it's a good thing I put this up here. You guys notice that? 1G. So that's where you got to make the 5-number summary and the box plot. What do I want to do with this data before I start to calculate the 5-number summary? Sort it. So hit stat, sort, and tell it which list you want to sort. And now it's in order. Yay. So the lowest I can see is 29. The highest was 63. Put that in there, right? So like we did earlier, if I want to calculate, yeah. So now I can actually see what's Q1. This is what we did earlier. What is Q1 going to be? I love it. It's just the fourth data point. I love that shit. Yeah. Q2, what would I do? Yeah, cut it in half. 50% of 15. So the 8th number is the answer. The 8th number is... You'll notice down here it tells you where you are. It's kind of nice. I got 45. And then, get out of here. Give us some more room. Q3. Real quick. Some of you guys will get this. Yeah, I could do some work here, but look, didn't I have to go 4 in from the top to find Q1? I could go 4 in from the bottom to find Q3. Or I could just do 75% of 15. Yeah, which is 11 point whatever, you round up to 12. And then the 12th number is, looks to be 52. So there's my 5-number summary. And then how do I make that into a box plot? What do I do? Number line. I love it. Kick ass. So number line. Maybe start where? I would start maybe 25. I know the first data point's 29, but then I can just go by 5s or 10s, whatever you like better. Let's go by 10s to see what that is. 25, 35, 45, 55, 65. Yeah. Let's see if that's enough detail. I'll get to this for myself. So let's see, 29, pop, 40, pop, 45, where do you go, 52, what's that, 15 right there, plop, and then 63, bam. The biggest mistake people make is the scale is all freaky. I love the people that do this, 29, 40, 45, 52, 63. Holy shit. So you're saying that 11 equals 5 equals 7. It's back to 11. That's what you're claiming. That's a problem. Okay. In general, graphing, that's one of the biggest mistakes, is to base your scale directly. No, you base your scale on letting everybody fit. And the scale has to be consistent. I love it. Yeah.
It's okay to like read it off, right? Let's just say I do 2s.
Yeah, you can have a different scale as long as it's consistent. Yeah. You could have gone by 7s, whatever you feel like. As long as it doesn't go too crazy, or it's like this. And as long as it's consistent, every step you take. Every cake you bake. Watch it. Yeah. How do you determine if it's nominal?
Yeah, like it's just labeled, like for example, is we talk about the vegetables.
Yes.
One point we said percentages, and then some percentage of portion.
You ready? You ready? All the levels, here we go guys. All the levels of measurement are about comparing two data points. I know that percentage requires you to divide to make it, but that's not coming from the comparison of two data points. So if my data was number of birds in a tree, a data point could be 2 and another one could be 4. 4 birds, 2 birds. You divide those, there's twice as many birds in that tree. That makes physical sense, ratio. But I can have hair color and I can get the percentage of people with brown hair. It doesn't change the fact that it was hair color that I was writing down. So whenever I give you a percentage in that kind of problem, it's basically almost always going to be what I did with the data. How do you tell if it's nominal, ordinal, whatever? You look at the actual data. So the data for that problem was like green beans and broccoli or whatever. That's names of vegetables. That's nominal. Nominal does not mean number again. Some of you guys seem to think nominal means number because it sort of sounds like number. No, it's nominal as names.
Could that be qualitative data for?
Yes, so basically, this isn't exactly perfectly true, but it's close enough to say this. Nominal, ordinal, qualitative. Interval ratio, quantitative. And the interval ratio makes sense, because we have to be able to do for an interval. What has to make sense for an interval? Shit. You have to be able to subtract them for an interval, right? The subtraction of two of them makes sense. So I can subtract two zip codes, but the answer, does it mean something? No. Right? So subtraction has to make sense for interval. That's got to be truly numerical then if I'm going to subtract it. But what about ratio? Ratio, of course, is what has to make sense. Division has to make sense. The name gives it away. Ratio means divide. So how do you figure it out then? Well, you give yourself two data points, 5 and 10. And then you say, when I divide those, does it make physical sense for the problem? So yeah, I know 10 is twice 5, but if it was temperature, 10 degrees is not twice as hot as 5 degrees. It just isn't, because 0 is not in the right place. 0 doesn't mean what it's supposed to mean, so that would be interval data. Oh yeah, 11 was... What's the key word in number 11 that makes it obviously parameter? Yeah. 42% of all Americans are tired of hearing about the election. I wrote that before the election, and it still is true now. So, how would you change it to be a statistic? What would you change? Probably the word you just pointed out. So what would you say instead? 42% of... There's a lot of different answers here. Instead of saying 42% of all Americans are tired of hearing about the election, you say 42% of some, or a subgroup of, or 37 selected. It's up to you. Just like the homework, you can be as specific or not as you want to when you make an example of it. Like it. Yes? Definitely don't have to do the cumulative, but the relative is part of what I'm asking you for, so you have to do the percentages. Cumulative, you can do if you feel like it. I don't care. I didn't ask for it, so yeah. By the way, if you're having a lot of trouble with the homework, you could ask questions right now, obviously, or any class. If you don't want to ask in public, you can come see me in my office. If you don't want to see me, because you're tired of seeing me, you already see me twice a week, and you're like, that's twice too many times. You can go to the couple of different tutoring places, right? Or you can accept your fate. It's one of those things. Homework, some of you guys are like, why does he have to say this? But homework is unbelievably important. Some of you guys have stumbled across the solutions manual for the book. It's out there. There's a Pirate Bay of instructor textbook solution manuals. If you don't know what Pirate Bay is, you've led a good life. You just keep on leading a good life. I'm not saying this to you so you go look for it and find it. I'm saying this to you, if you found it, try to forget you found it. It's just, I'd rather you make a mistake on every damn homework problem because you're honestly trying, and I can help you because I can see what the trouble you're having is. If you just give me your right answers, what can I do with that? I can't do shit with that. I can't. And the homework is not worth anywhere near enough to save your ass from bad test grades. And yes, you can make corrections, but really I don't give you that many points back. I give you enough to make some kind of a difference, but it's not going to save your ass from failing every test, right? So if you're making a plan based on that kind of thing, you got to change your plan. Yeah.
Can you go for 1, 2, 3, question 36?
I asked if it's like a valid question.
Oh, did I assign that one? So a question says, do you prefer the delicious taste of brand X? Oh, I love this question. I didn't assign it.
Yeah,
I love it. So you ready? So the question says, do you prefer the delicious taste of brand X or brand Y? Why would that possibly be not a fair question? Why? Yeah. Even if I took that word delicious out, to be honest, there's a sort of weird inherent bias. Do you know, have anybody voted before? Do you know about the, depending on the party in power, you can order the ballot in different ways. And whoever's name appears first in any section gets a small bump just because they're first. Not because they're the better candidate or any of that shit. Just because you have people going, look at me, I voted. Yo, I voted. You know, it's like no thought involved. They just, every first one, they just put it. So unfortunately, that's always going to be in there, right? So the fact that they said brand X first, sometimes people are like, yeah, the first one you said is fine. And then they come out with the commercial, look at that, 4 out of 5 people prefer brand X. Yay! Yes?
I think they scramble the ballots in California, so different people have different orders.
Oh, do they? I didn't even know that. That would be awesome. That would be different. Then somebody would be upset somewhere, I'm sure, but oh well. All right. I have to look into that. I like that. If that's true. It's surprising. All right. So you're just curious about that problem?
Yeah, I did 36 instead of
Oh, okay. Well, it's a good question because there's a whole class you could take about creating fair surveys or fair questionnaires.
delicious. I was like,